So the cotangent function, y equals a cotangent of bx, the domain will be whenever the sine of bx is not 0. Okay, so this is going to be the set of all x values such that bx is not a multiple of pi. In other words, x is not equal to pi over b, or any multiple of that, k times pi over b. The range, we saw our function went up forever and down forever. So our range will be all y values from negative infinity up to infinity. The period of just the cotangent of x is pi. However, this scaling factor will adjust that, and it will be pi divided by the absolute value of b. We saw some symmetry in our function. It was symmetric with respect to the origin, meaning that this is an odd function. Or in other words, the cotangent of negative x is equal to negative cotangent of x. The x-intercepts of the cotangent function were when the cosine, the numerator of the cotangent, is equal to 0, which is when bx is pi over 2 plus any multiple of the period. So that is our x-coordinates of pi over 2b plus any multiple of the period, which was pi over the absolute value of b. And then, of course, the y-coordinates there were 0. The vertical asymptotes are these places that are cut out of the domain. So that's x equals any multiple of pi over b. And finally, the key points. The key points of the cotangent function are when the cosine and the sine are both equal to each other. So that's going to be when our x-coordinate is pi over 4b plus any multiple of the period, k times pi over the absolute value of b. And the y-coordinate there was 1, but this scaling factor of a will bump that up at a. We also had a key point at pi over 3b plus any multiple of k times any multiple of the period, and the y-coordinate was negative a. These key points I find easiest to find by simply finding the point halfway between the center, the x-intercept, and the asymptotes.